Bismillahirrahmanirrahim. Assalamu alaikum. Yes, thank you very much, Mavish, for the introduction. Now, today's session, I would like to talk about the data visualization with R. As you know, all about the R is a free software. So this was the very reason we have chosen this software. No ethical issues we can process over there, as well as we can use very much sophisticated statistical tools in that. So that's why I would like to continue with my target points. As you all are aware, there's the huge information as a data is pouring around us. So we need to cater that data. And it's certainly by the lightning speeds coming over there around us. So there are some techniques and tools which can handle the big data. One of them is known as the visualization. So visualization through R, in which we can handle the trends, the pattern, the outliers, the system related to it, and address the answer to the different questions. Even those questions which we don't have, we have it in our mind. When we see the data set, we can say, oh, why so? It's going to be so large bar over there. Why this is clustering over here? So we can define the patterns, the trends, the system related to the data through visualization. So this is one of the tool, I must say, to handle the big data set. And this method, you say, is placing the visualization context, such as we can make the graphs, the charts, the maps. You are very much familiar with that. And the main goal is to filter the large data set into the visual context to understand the complex relationship between them. And large is really meant for large. You will see the data which we will be utilizing here. I've chosen the two data sets. They are already built in from the R repository for your ease, that you can easily get it. So one is known as the Saratoga houses data. You see how many observations it's have it? 1,728 observations it's have it with the 16 variables. So it's a quite big data set as well. The second data set I would like to utilize in this very presentation will be the academic salary. The academic salary data is containing 6 variables with 397 observations to each of them. And it is also a very big data set. A brief introduction about the data sets. These are the observations related to, although you can get this from the sites, from the repository, the price, the lot size, the age, the area, the percentage of the college students, and blah, 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 blah. So over there. The second data set, we have it in the hand, containing the variables named rank, the discipline, year since they have done PhD, year of service, and gender or sex, you can say. So come to the point. What we can do with this data set? Firstly, we will utilize the salary data set. Just get rid about this grouping firstly. But you can see it into the figure. Into the figure, you are seeing just a scatter plot. It's not drastically different things. You can say everybody can make the scatter plot. The different thing is that we are handling at a time 1,728 observation. Manually, it's not possible, obviously. And there are so many other sophisticated software which you can handle it out and take on one click the scatter plot. So it's not drastically different for you. But it's sending out some relation. What relation it's sending out over there? That year, since they have done PhD and the salary, they have, you see, the conic, the increasing sort of relation we are clearly seeing over there. So fine, we can get it. What is new in that? The new in that comes into the next slide. Yes, here. If you can see it here, then what you can see, we are superimposing an other variable. We are superimposing an other variable like the rank. It's the assistant professor, associate professor, and the full professor over here. So by the coloring in the last slide, you see, it's just a scatter plot over there. We have nothing over there. It's just simply we are handling the big data by our software. Nothing drastically different. But in the next slide, you see, we are handling one more variable. We are superimposing it by colors. Now it's quite clear that the red is representing the assistant professor, fine. Then the green is associate and the full professor over there. So in a one glance, you can say there are more and more full professors over there. Fine. Then the cognitive test, it's come into our mind, and we can see or map one more variable on that. Which variable is this? Okay, we want to map how many females and how many males over there. You see the beautification of that nothing goes to be disturbed in the base graph. The base graph was similar, the trend was similar. With the two variables, we are superimposing with the shapes and the colors, different variables. Now you can clearly say the triangular with the blue colors are referring the male professors. So in data set, we are having more male professors over there. I think so it's quite clear. It's easy to comprehend. When you can see 1,728 observation, I'm quite sure that you are not able that within a second you can describe such a phenomenon, that there are more full professor with male categories. No, but with the visualization context, even though a layman can tell us, yes, there are more and more male professors over there. And then we can see more and more even the associate professor males over there. So more triangulars means the male, and the circles refers to the either it's a pink, green, or blue. It's going to be for female. So this is the beauty of visualization. We are handling the big data, and beautifully we are representing the data set with the 4 or 5 variable at a time by seeing its trend. So these are the corresponding codes, which we will be doing in hands-on session after maybe maximum 10 minutes. So in a nutshell, what is the grouping? That is known as grouping in R. We have done visualization through grouping. What is the grouping meant for? In grouping, the values of the first two variables are mapped to the X and Y axis, obviously two plane. Then additional variables are mapped to other visual characteristics such as color, shape, size, line type, and transparency, etc. Grouping allows you to plot the data for multiple groups in a single graph. What we have done, it was the same thing. It was complying with the same interpretation that we have done the plot of the data for multiple groups into the single graph. So it's allow you to plot multiple variables in a single graph. That's it. Any question regarding that, or we can tackle the question answer session at the end as you like. You may ask the question, no problem. Now this seems to be the scatter plot, a big plot by grouping in the visualization context. Now all of us are, I think so, very much familiar with the bivariate relationship. And usually if you will talk about the bivariate relationship, firstly comes in our mind the correlation. The correlation is known to be like here. This is the correlation plot. You see, you are handling at a time, it's supposed to be 10 or more variables over there. It's from the Saratoga House's data that we are utilizing it out. It's there. So it's meant we are handling on one click very much big data and tending out their relation. What's the red or the pink colors is referring over there? The more and more red is referring the strong positive correlation between the two variables. And what the blue colors is referring over there, the strong negative correlation over there. But certainly being a statistician, we just need to refer this sort of matrix correlation plot. We need the numerical justification for that as well. As you know, all are aware that the correlation is ranging from -1 to +1. If it's tending towards -1, the two variables are highly correlated in the opposite direction, negatively correlated. It's a strong negative correlation, means -0.98 meant for strong positive negative correlation. Okay, I will enlarge the screen, my dear, with you when we will do the hands-on session. Okay. Then it will be The diagonals is what they are referring the upper diagonal and the lower diagonal. You can take the full correlation plot or the lower diagonal or the upper diagonal plot. It's referring you the same information. We will go for the hands-on session. It will be more explanatory for you. Then I have one activity for you, which I'm holding it constant yet. And the last, we will talk about the multiple linear regression. And certainly we will not go into its numerical aspects. We will go into its visualization aspects over there. So now I would like to show another screen of the RStudio, and I believe you all have the RStudio with you. So I'm sharing it out, the RStudio with you. Can you please see my screen with the RStudio console and the 4 windows over there? Okay. Now, what the 4 windows is referring to you, I will explain it in a quite explanatory manner for 2 to 3 minutes, that you will be able to open your RStudio and go side by side with me. So you can see this is the first window, simple words. There could be so many difficult and technical names for that, but you can refer it this window. As you can see, there's the split of the 4th window, 1, 2, 3, and 4. So the first window is referring the input window, in which you can write up your script, your commands, your functions, your syntax, whatever you call it. And in the second window, you can take its output. You can see the results, okay? What about this third window? This is the environment window. In the environment window, whatever you will do it over here, it will be save it out, and you can see it during the session that this, my data is saving over here, my variables are saving over here, and blah, 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 different things. And this 4th window will be utilized for the multiple purpose. It can handle the packages, it can handle the plots, it can handle the files and help menu over there as well. But we will usually talk about the plots, display, and the packages. Yes, one more thing. There are 2 sort of data set you can utilize into the R. One is known as the base sets, and other are known as the computed data set. For the base data set, that I do believe that you are familiar with IRIS. IRIS is like the base data set. You just write the IRIS and view the IRIS. You just see the pop-up window with the output of the IRIS data. You do not need to make any sort of calling the package particular for that, but for any contributed data set, you need or refer to a package, particular package. Like I was telling you about that I'm utilizing the 2 big data sets over there, one from the Saratoga houses and one from the salary data. They are the contributed data sets, not the built-in, not the baseline. So contributed data set, for utilizing the contributed data set, we would like to call the particular package firstly, then the respective library, and after that we can utilize it. And it was very much clearly mentioned into the prerequisite recording. I'm hoping that you know all about it. Anyhow, now I've given you 2 minutes for open your RStudio, and these are the respective libraries which we needed prior to this session. Look at here. I'm just clicking it out because I have already done for that. So it's giving me the output. In the output window, you can see it's going to be blue. If it's blue, so it's meant it's working very well. Nothing went wrong. For example, maybe most probably in your case, it's not getting the blue because firstly you are doing. For example, firstly, it's the read R. So what you can do if you're not getting such a beautiful output like the blue libraries all over here, and you are having some caution or the warning messages. So what you can do for that, how you can get rid or how you can make it clear. Go to the packages, install. You see this pop-up window over here, repository directly from the Crane. Right up in the packages menu, read R. That's it. It will be coming over there. Just install it. Actually, I have already in the hand, so it said don't be do again and again and again. It's going to be well enough. So you have to do it. Firstly, install the respective package. Like ggplot 2, install. You have to wait until it's working, and you can see it in the output window that it will give you the caution for like this: successfully, ggplot2 is successfully unpacked. Yes, somebody was asking that how it's different from Sarah, or if it's telling me that how it's different from SPSS. My dear, SPSS is a just quite user friendly, as well as it's paid. Here you have to work beyond a certain limit, means you have to learn about how many packages and how they are working, what the particular package is working for what particular purpose. So you have to learn it because it's free. There is no ethical issue for that. So that's why we're choosing the R. And it's quite more sophisticated. So many extra techniques and built-in function in the more modified and upcoming latest version in R, which are not, I'm not sure, but it's quite sure that it's not handling by SPSS directly. So that's why. No, we are not using the dummy dataset for this session. We will utilize the real dataset. Okay. After utilizing or calling all the libraries, what you can do? You have to write this command. This is the syntax. We cannot be bifurcate the syntax. I'm not saying this is the best way. There could be other ways, but this is the easiest way to call any, you can say the file along with its package. The file name is salaries, and it's a case sensitive. So S should be capital over here. You have to write data, then small parentheses over there, then write the name of your data file. The salaries is the name of the data file. Then you write the corresponding package in which it is. It is in the car data. And the same format you need to utilize here into the small, C is small and D is capital. If you will write vice versa, it will not work a bit for you, certainly. So we will utilizing it, that data salary package from card data. Just run it. It's blue, it's fine. So I would like to see how many variables and how my data looks like. Just run it to see view. So it will be displayed over there. You see, you having the ranks, the discipline, years since they have done PhD. So sex, salary, years service. So you have it, the quantitative as well as qualitative data set along with you. So the next, for the ggplot, GG stands for Grammar of Graphics. So we have already downloaded its respective package, so it will work it for us. How it's work? What the command is saying to you, ggplot salaries, you have to write the data name. Then you need to define your axis. Along x-axis, you would like to take the year since they have done PhD. Along the y-axis, it's salary. You read the concept of the dependent and independent. The salary is depending on year since they have done PhD. Although for the scatter plot, we do not need to be worried about that, but it's more sophisticated to be worry about the dependent and independent variable. Like the salary is the dependent and year since they have done PhD, it seems to be the independent here. So that's why we are putting like this. Then plus geom points. What this geom points will do for you? I will see and show you. This label, LAB stands for labels. Labels is arbitrary for the beautification of your graph. Academic salary by year since they have done PhD, you are giving just the title for that. When I run it, you will see wait a minute, that's it. The ggplot salary. So what there, built in under R, yes, it's fine. And we are having it like this. The similar plot, you can see it here. What you have observed into the, they have done PhD and the salary. It's a conic trend, increasing trend. Fine. But it seems to be just the scatter plot, as I told you. And what's the geom points is working over there? If you will remove it, for example, you said, just play with the commands, my dear. Don't write it. You don't write it, what will happen? That's it. It's having no information. The X and Y variables, they are storing it out, how to display it. So for displaying purpose, you have to write the geom points. When you write the geom points, it can be geom points, it can be geom lines, there can be different things, we can do it over there. And whenever you have seen the small parentheses, it's become the function as well. You can play with that to utilizing by having more and more size of the points, increasing size or decreasing size. You can increase or decrease the size of the points and line, as well as you can make it more transparent or opaque. So go to the next, that what it's going for us here. Now we are superimposing the rank along with the color. So how this is working? The same till here, salary, the data file name, the axis we have already defined. And along axis, you need to refer third variable. Introduce the rank along with different colors. You may ask to me, we did not define the colors. These are the by default. This is the beauty of R. It's automatically fix these things for you. You just need to define the color and the rank. Rank is, my dear, like the categorical variable. One thing should be clear here. You can superimpose the categorical variable along with the quantitative variables. Not the quantitative to quantitative. There's some other techniques you can utilize it, but not in grouping. So in grouping case, you can take two quantitative variables and then superimpose through the colors as well as through the shapes. So through colors, we are utilizing the ranks, and ranks are in assistant professor, associate professor, and full professor category over there. So it is over there. And the rest command is, you can see, same. Nothing is drastically different. So what about the third one? Now, again, I will say that the cognitive thirst comes over there, and we can see how many males and the females over here are assistant professor, full professor, or associate professor. We would like to see it into the graph. So here you can see the similar output which we have discussed in the slides. So the circle are referring, whenever the circle you have seen, pink, it's pink color, green color, blue color, it's referring the female, and assistant for the pink, associate for the green, and blue for the professor. So majority are again male, we can infer from this data set. How this command we have written over there, I can explain for you. The similar is over here, salaries, the data name of the data, the axis we have defined, and in the axis we have superimposed the colors firstly, and then the shape. As I told you, along with the two quantitative variable, I'm sure you have an idea about the quantitative variables, which are continuous or discrete in their nature. You can superimpose the qualitative variable. The qualitative variable can be the ordinal, like the ranks is the ordinal variable, and the qualitative variable can be the nominal, like the sex or gender is nominal variable. It's doesn't matter you have write firstly male or female. So nominal and ordinal variables can be easily tackled out with the quantitative variables, and we can see the more sophisticated graph and interpret it in a more meaningful manner. That's it. Now the bivariate. The bivariate, as I told you, whenever we comes with the bivariate relationship, firstly comes in our mind correlation. The correlation is having its very sophisticated name, Pearson product moment correlation. It's quite difficult to say, or you can say simply R. It's having its own assumptions that you need to be correlate to quantitative variables, which are usually follows the normal distribution. It's the statistical aspect for that, my dear. And I can say, come to the visualization context. For the correlation, I'm utilizing the Saratoga Houses data. Saratoga Houses data, also the contributed data set. It is not the, you can say, baseline data set. It is the contributed data set. When I said contributed data set, it's meant prior to that, we need to call its respective package. The package is Mosaic. Mosaic data contain Saratoga Houses. So firstly, you need to call Mosaic, install Mosaic. I have already done. So you have to do it. And then library of Mosaic. I can write it for you. Like library for Mosaic data. After calling the package, you can call its library, then it will be easily work it for you. Now, this command is quite similar what we have utilizing in the prior session. That is the data. Data is basically the function. And in the small parentheses, you have to write the corresponding name of the file, which is the Saratoga Houses, and the corresponding package which contain this file, which is the Mosaic data. I would like to run it out and then would like to view it, how the Saratoga Houses data looks like. Is the price, lot size, age, land value, living area, percentage of the college students living over there, the bedrooms, the fireplaces, and blah, 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 blah. So many variables. We have it over there. It's again the qualitative one you have it, and some information like the quantitative you have it. As I told you, for the correlation, we need the quantitative variables. So, my dear, we have to be more sophisticated for the quantitative one. DF is any arbitrary name data file like this. I supposed to be call it data file. So that's why I've written the name DF. You can write your own name. This DF is just arbitrary. Fine. Then this sign, it's of greater than, then the dash sign, and select underscore if is a function. You have to write select underscore function as it is. If you will write select if, it will not work it for you. And from which package we are utilizing it out? We are utilizing it out from the dplyr package. Kindly note it for you that the selectors function is, I can comment it over here for you, dplyr, dplyr. It's a dplyr package which we have already installed over here. So this command would work it for you. You may ask to me, how we come to know? We can come to know all these things after the, you can say, much more practice with R, with different data sets, with packages, and blah, blah, blah. So after viewing the data set, you just call it. Okay, the select this function could not find. So we need to be call its library again. Dplyr. Dplyr, it said it's a built-in function. Yes, we know. It is giving us the caution for the more sophisticated version, 4.2.3. We are having 4.2.1. So it doesn't matter. You just click it again and it will be over here. And now the select this function is working for you. You see? The same, what we are doing over there. We are selecting, as I told you, for the correlation, we need the quantitative variables. So we said to the R that just call those variables which are is numeric. जो numerical aspects में है उनको call कर ले, जो quality aspects में है do not call them, because we would like to calculate the correlation matrix, and for the correlation matrix it is obligatory for the quantitative variables. Now it's R because it's just again the arbitrary name. You can write the complete name over there, correlation, blah, 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 blah for the data set, or simple R. These are the storing operator, you can say. The DF is the storing operator, the R is the storing operator. You are storing your whatever doing on the right side. What you are doing right side? Core, COR core, again the function. You are writing up the function for the correlation. You see, when I click on the core, it's displaying over there. X, Y, one variable is X, certainly, and second variable is Y. It's arbitrary, whatever the X, Y, Y, X. Doesn't matter for the correlation. You can write Y, X, X, Y, it doesn't matter. But two variable at least. It's pairwise relationship. To whom? To the data set containing in DF. In DF, it's having Saratoga total data set, which is having in the numerical manner. The all variables which are numerical in the Saratoga houses data set, it is over there, and they will be utilizing it for correlation. They will be calculating its correlation for the complete observations. Obviously, for the missing observation, which is another problem, we can tackle it out with something, some other tools. It's beyond this session. I can let you know afterwards if you are interested. But we are talking about the complete observations and calculating its correlation. Now, if you would like to see R, what's happening into the R, you can call it. See, it's going to be 0.1629186. It's too long values. We need to jot it down into more sophisticated manner and round it to the 2 decimal places. So that's why we are writing out round R. R के अंदर whatever you have stored it, उसको round कर दीजिए up to 2 decimal places. You are rounding it up to 2 decimal places. That's it. So now it's more sophisticated. You can see it, the output. It is giving us, fine. But we are interested into its visual context. So for the correlation, we need to call its library. And then the ggcore plot will be displayed for us. Okay. This, why we are always getting the highest correlation in the diagonal. This is obvious because rooms are correlated with rooms. So it is certainly the same variable it is utilizing. So it's meant for the half diagonal is basically is working for you. Either is the lower half or is the upper half. So we can see it into the R HC stands for hierarchical cluster ordering. True. Type lower. Means we would like to see the lower part of the matrix, the lower diagonal of the matrix. In the similar way, you can see the upper part of the matrix. So firstly, we will utilize it and turn it towards, just zoom it out. Here, you see it's clustering the highest order correlated value into the positive terms. It's clustering the highest order, whatever over there according to the data set, into the negative strong correlations like this and the low weak correlation. So the highest correlation, it's coming over there 0.73 between the living area and the room, and it is complying with the expectation that if the living area is more and more, then we can have it the more and more rooms over there. And the strong negative correlation can be over there, the bathrooms and the age. So it doesn't matter. It is inversely related rather than that. And the lower, the white is showing you, or the lighter colors is, even though in the positive or the negative sense, is letting you know that there is a low correlation. So this is the lower diagonal part. You are utilizing it for that. Similar way, the same information you can get it into the upper. It can be look like this. Now, my dear, I have one activity for you. I can give you 2 minutes. What you can do, yes, yes, Abu Bakr, you said, once again, please, where was the question? Mavish, can you please explain his question?
Hi, Itrat. So we don't really have many questions, but this is just one question that we have, that
Okay.
do we need any specific data type like factor, etc., or data structure for these two plots?
No, we just have the assumption, if we are interested in the correlation, then we just have the assumption that, as I told you, quantitative variables. As many quantitative variables we have it, like the age, height, weight, length, blah, 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 blah. In a data set, if we have it, 20 quantitative variables, so at a time on a one click with this command, we can get it out. That's it. Just this structure and assumption, this have it. Nothing else. Okay. So next is going to be, I have the activity for the active participant who are along with me, that I'm taking just a base data set. Base data set is in which you are not needing it out any sort of library or corresponding package. You just write the name of the data set, the familiar, all of you are quite familiar. I'm hoping it out that the iris data set, it's just write it up, view, and V is capital over there, and just run it. You can see there's sepal length, sepal width, and petal length, petal width, and species. You are very much familiar for that. I would love if you will calculate the correlation matrix for this. I can give you 2 minutes and you can see the commands. Just you have to write the name of your respective data set. Rather than Saratoga, just utilize for iris. So I think I can just give you 1 minute. You just copy paste the commands and write it up. And what the result you get it. Okay, I think so. We have shortage of time, so I can run it for you. You can do it the practice for other data set by yourself. This is like this, my dear. The iris data set, you have it, the selective, this the iris. Rather than the Saratoga, you have to write the iris is numeric and nothing else, practically. So you will see that's it. I can zoom it out for you. This sort of graph, you will get it. It's the upper diagonal and you have it the lower diagonal as well and the full graph. Now, very quickly, because we have a very shortage of time now, 15 minutes are left. For the multiple linear regression, I'm not going into the numerical aspect. Yes, you are right, my dear. That one session is not enough. So that's why we are giving you the prerequisite for that. And my recorded session is also with you. So along with these three, I'm quite confident that you can learn more and more. So just it's my request to listen it, what I'm saying, and just try to grab it. So the data, we have it, the Saratoga houses and the package Mosaic. I'm utilizing the same data set for the multiple linear regression model. Regression is meant for at least one dependent and one independent variable. If you have one independent, one dependent variable, it means to be the simple linear regression model. If you have more and more and more, and practically we have it more and more and more independent variables. So it seems to be for the certainly multiple linear regression model. For the one dependent variable and more, at least two and more independent variable, we have to write the command like this. Again, I will say this is arbitrary. Houses underscore LM. This is the name, just arbitrary name. You can give your own name. And you're storing, this is the storing operator, storing name in which you would like to store your data set. The technical command is for linear model is LM. Then your response variable like price, and then you have a tilde sign like alif madda jaise hota aapka tilde sign. From where you can get it, it is on the top left corner where the number 1, 2, 3 have been started. The first is known to be the tilde sign with the shift. You have to write it up, your response variable, your dependent variable. Price is depending on lot size, age, land value, living area, bedrooms, bathrooms, and blah, blah, blah. And again, at the end, you are referring the data name. The data for which it comes from, all the variables are Saratoga houses. Now we would like to run it. And this is again, the LM is the function linear model and it's the base function. So you just run it and it's blue. It's nothing to be happening wrong with that. Then we can take the summary. This is the quantitative aspects for that. Is the quantitative justification. All the variables are highly significant over there. But I am interested into the visualization context. So for the visualization, we can see the diagnostic tools. The diagnostic tools are, is the response variable is normally distributed? We have to see it out. Is there is a linear relationship between the dependent and independent variables? Is there is a homoscedasticities? Is the technical word known to be simply equal variability? And then the leverage plot, the inferential points into the data set. These 4 points are known to be like diagnostic plots, which we can see it out through this plot command. You see in the plot, I have write it out the name in which I have stored my linear model. If you will write DF, so you have to write DF here. If you have stored it, your entire data set in LM into the fit, for example, so you have to write fit here. Whatever you have written over there, it's houses underscore LM you have written over there. So in the plot command, you have routed houses underscore LM. Now, after that, you have to come into the output window and press the enter the first plot, zoom it out. The first plot you can see over there is the residual versus fitted. How we can interpret this graph? As I told you that I'm interested in the visualization aspect. So this is the first agnostic for the multiple linear regression. And we can say the residual versus fitted graph is telling us that the name is linear model. Even it's a simple linear regression or a multiple linear regression. So it's a linearity should be over there. So linearity can be assessed between the dependent and all independent variables through this graph. How we may assess? You can say this is the baseline. The gray line, dotted line is along the x-axis is the baseline, along with this red line is your fitted regression line. If it's along with it, it's a good sign. It shouldn't be so much divert from the baseline. This is the first aspect. And the second aspect you have to observe the points. You can see there is a clustering over there, but we can get rid for the time being. We can say the points has to be evenly distributed. Evenly distributed meant for half the points above and half the points below. Approximately, it's going to be same. So we can say there is a linearity stance. That's it. Is it fine now? Dotted line is the baseline and this red line is a...
Excuse me, Dr. Itrat, we cannot see the graphs on the screen.
Uh-oh, why so? I'm sharing it out the same way. You can see this graph?
No.
No. Okay, so I would like to share it again. Wait a minute.
Somehow it feels
Is it over
that the
here?
screen, yeah, now it's visible.
Okay.
Thank you.
So the residual versus fitted, it's meant for the linearity, as I told you. It's the gray dotted line is the baseline, is the rule of thumb, you can say, because residual, it's not a good scene. It has to be 0, so it's going to be 0. So the residual versus fitted. Fitted is going to be your fitted regression model, the red line. And I said how we may say this is the good fitted regression model if the points are evenly distributed, more or less half the points over there and half the points below that. So it's even distribution of the line. So we can say this is a linear trend into the response and linear relationship between the response and the independent variable. Although we can see some inferential points over there, which are discussed in the later on. Now, the second is going to be, so I would have to show you again and again the graph and share it. It takes more time, I think so. The second graph, we can take it after the click and zoom it out over here. It's known to be the quantile plot. Yes, I'll let you know, my dear, for solution for outliers. Just wait for a while. And this is second is the quantile plot. Okay, it seems to be like this dotted line again, the baseline showing the normality. It's the quantile plot for the normal distribution. But this snake style line, a thick black along with us, along with that dotted line, is like the pretty good normally distributed data set. If it's along the dotted line, then it's going to be a normally distributed data set. But if it's beyond, like it's having some heavy tails, say you can see the points are going beyond that. But approximately 80% of the data is along with the dotted line. Now the third point is going to be the third graph is I will enter it out and see the plot for scale. I can share it out. It will tell us the, okay, there is a special saving for the graphs, my dear. I will let you know the all answers afterwards, please. Just one more minute, give it to me for the explanation of the scale and location plot. The scale and location plot is telling you again, there should be this red line, which is your fitted regression line along the x-axis. It has to be. And the points, second point is has to be evenly distribution of the points. Evenly distribution of the points, we are seeing it out, but a bit diversion from the x-axis. It's not pretty good along the horizontal axis. So that's why there is a variability into your data set. And yes, there are more and more plots which we can discuss, but I think it's better idea to give the answer for your questions one by one. Now, Mavish, can you please tell me the questions?
Thank you so much, Itra. This was such a great session. Actually, I'm a new user, you can say, to R. And although I don't know the basics of the software, but I could follow what you were saying. And your session has, pretty much motivated me. And someone else also, Dr. Samira Akram from Punjab University, also said the same, that, your session was so energetic and it was so simple to follow that it kind of promotes some sort of motivation to try R. So we don't have many questions. This was an information-rich session in itself. And we have one question from Mohammad Asghar from Virtual University, where he has inquired for the solution of outliers.
Yes. I would like to suggest, sir, that we can increase, obviously, the data set we have already pretty good in the hand. It's 1,128 observation, although we can increase it. Being a statistician, most probably you know that more and more data set, more and more reliability and error has to be reduced. But the second case is that more variables, more related variables can be added. But one more thing, it can be the type, if the inferential points is over there, if you remove it, so maybe you will get a higher degree of the R-square, adjusted R-square value, which is another tool, for the assessing the diagnostic, numerical diagnostic tools for the regression. So you firstly can delete and check the R-square. Is it really an inferential point or not? And if your R-square is going to be decreased, then you go, do not delete it, obviously. You need to add more variables into the data set, or the more related variables along with your response variable, I say.
Okay, thank you. We have another question from Dr. Faiza Ghaffar from University of Peshawar. She's asking that how can multilinear model be developed in R?
This is the multiple linear regression model, my dear. Multilinear model is the multiple linear regression model. Yes, other ways are like this. When the response variable is going to be normally distributed, this is the way what I just talked about. Now, there are so many other types, like distributed. It's not normally distributed. It's binomially distributed. It's not normally distributed. Means to say there are different types of the response variable. So we may use, obviously, the logistic regression for the binomially distributed data set. And there are different means and different techniques for, obviously. And it's a bit difficult, obviously. Not a linear model is working for that. Yes, I can suggest, if there is a little bit bifurcation, then you can transform your response variable. So many transformations over there, like you can take usually the square root transformation of your response variable to make it normal. You can take exponent transformation. You can take sine inverse transformation. You can take square root transformation for your response variable. These are the well-known transformation which can make your response variable if it's a bit divert from the normality to be normal, and then you can apply the linear model for that, because it's the first and foremost condition for the response variable to be normally distributed. Otherwise, you cannot apply what we did. And there are some other tools like other logistic regression, as I told you about, and mixed modeling, and something else has to be done for that.
All right, thank you so much. This was quite in detail. Ijlal Heather has asked that how can we use other functions instead of ggplot2 for data visualization? Are there
Yes,
any
my
other
dear.
functions?
There is a tidyverse basically package. It's take too long because it's a big umbrella of the packages in which you can get so many related packages. Tidyverse, Tidyverse, Tidyverse package, in which you can have number of packages. If you install the Tidyverse package, you have the number of packages which are dealing with the data visualization techniques and tools in that. So I think so it's better idea to install Tidyverse priorly to that. ggplot obviously is one of them. So it is having powerful tools in that, but ggplot is the part of Tidyverse. Again, I said Tidyverse is a big umbrella for the visualization tools.
And we have another question from Ramisha Mehtab from Forman Christian College University. And it's a very interesting question, actually, where she's asking that if the variables used in the regression are strictly quantitative or a mix of quantitative and nominal ordinal types, will we write the code differently or would it be the same kind of composition?
My dear, is the same kind of composition. Just the restriction for the linear model is for the response variable. Your response variable has to be quantitative, continuous, and follows the normal distribution, because the error has to be normally distributed for that. The independent variable can be qualitative, quantitative, nominal, ordinal, discrete, continuous. It does not matter at all. That's it. Otherwise, you have to go for discriminant analysis and factor analysis and something else for that. But for the linear model, just a restriction, we can put it on the response variable. That's it.
Thank you so much. I think Mohammad Akhlaq Saab, your question is being answered, that if this is a multivariant data, then how to use the model and how would we write the command for different variables, dependent and independent variables. Ithrat has talked about it in detail. Another generic comment that we had, Sumaira from Punjab University had inquired that apart from, understanding the basics of this software, what other essential skills do users need to build in order to be proficiently using this package? So in my personal opinion, I think it's all about practice. Exactly. What do you think?
It is basically all about practice. And why the statistician utilizing it more? Because it's more sophisticated for statisticians. It's quite similar for the Python, but the Python is more user-friendly for the CS-based students and teachers and faculty and domain people. But for the statisticians, I think so it's more friendly for us, and it's more practice should be required, my dear.
Thank you so much. It actually looked like a computer language to write commands for customized data representation.
Yes, exactly.
So it's not very technical, very, research oriented. And the best thing about this package was that so much customization could be done.
Exactly.
It really offers a space for personalization of data.
Exactly. You're pretty good, right?
Yeah. So thank you so much, Ithrat. I think we don't have any other question, but I would like to ask you that how do you see artificial intelligence impacting the future of this package?
Yes, my dear, it's not the command dot language as well, as I talk about the contributed things. So you can contribute in that, and artificial intelligence is not much higher than the human mind, I think so. So contribution is over there all the time, obviously. And there's one example I can give it to you for in this context, that the students are give it to me a very much good sophisticated assignments through AI. How I get it for that? I just ask the Viva for that. So there are some, solutions we need to contribute it over there.
Yeah, I get that from the student's point of view. But if as a new user, I want to take help from artificial intelligence or ChatGPT or Gemini maybe to write commands for what I need, Do you
Yeah.
think that it has the
Yeah, it's a
potential
better
to
idea
help me?
for the, yes, for the experts, for the researchers, for the faculty who are not to be utilizing into the other way around, into the positive sense. I do recommend it. Yes, you
Yeah,
can.
that's awesome. Actually, this is very helpful. And I think, Sumaira, you can add this to the list that you can make the, Gen AI your tutor to learn our software. So now I'm going to share the session evaluation poll with you. Thank you so much, all participants, for staying with us. We had about 138 participants. So I'm going to share the session evaluation with you. Please give us your responses. And thank you so much, Dr. Itrat, for making time for this. You have these two questions on your screen. Please choose your answer.
Okay.
And thank you so much for staying with us. Thank you for joining in.
Thank you very much. Thanks.
All right.
Okay.
Khuda Hafiz, everyone.
Khuda Hafiz. Allah Hafiz. Okay, it's going to be fine. End meeting. यार इसका end किधर है? Okay, my dear. Is it so wonderful? मैंने कितनी excited teacher है class में. कितना प्यार से वो आपने